Now I'm going to talk about colloids. A colloid is a substance that is microscopically dispersed throughout another substance. So the word colloids comes from the Greek word cola. So the word cola means glue. So colloid particles, they are glue-like substances. That is why this name was coined as colloids. So principally, a colloid contains a dispersed phase, which is a discontinuous phase, and a dispersion medium. The dispersion medium is a continuous phase. So you can see this figure here. So you can see very fine particles which is dispersed in a medium. So this medium is called as dispersion medium, and the solute particles which are dispersed throughout this medium is called as dispersed phase. So colloids are generally belong to this particle size range. They are between 1 nanometer to 100 nanometer. And these particles, they are invisible to the naked eye, but using an ultra microscope or an electron microscope, we will be able to visualize colloid particles. You can broadly classify uh, a dispersed phase and a dispersion medium together or a mixture into solutions, colloidal mixture, and suspensions. So what is a solution? Solution generally consists of a solute and a solvent. If the solute is completely dissolved in the solvent, we call it as a true solution. So particles such as atoms, ions, or molecules which are very, very small in diameter form the solutes. And the solvent is usually a liquid. The second one is a colloidal mixture. So here the particle size of the solute is a little bit bigger than the particle size of solutes in solutions. So the particle size is intermediate. It is neither too small nor is it too large. And the third category is suspensions, where the solute particles are larger compared to those in solution as well as in colloids. So on the right side, you see an illustration of how a solution will look like, a colloid looks like, and a suspension looks like. So the particle size keeps on progressively increasing as we move from solution to colloid to suspensions. This picture shows a very good example of solution, suspension, and colloid. So when you mix table salt in water, it is an example of a true solution. And if you mix rice flour in water, that forms a suspension. And milk is a very good example of a colloid. So let's look at the classification of colloids. So colloids can be classified based on a number of factors. Some of these are given here. So colloids can be classified based on physical state of dispersed phase and dispersion medium. We can also classify it based on the nature of interaction between dispersed phase and dispersion medium, based on the molecular size of dispersed phase, on the appearance of solids, and based on electric charge of the dispersed phase. Let us look at each one of these. So this classification is based on the phase in which the dispersed phase exists and the state of matter in which the dispersed medium exists. So a gas in gas, or if the dispersed phase is gas and the dispersion medium is also a gas, they form a homogeneous mixture. No matter how many gases are there, they form a homogeneous mixture. So they do not come under the category of colloid. A gas in liquid is called as a foam. An example of foam is whipped cream. A gas in solid is called as solid foam, and an excellent example is bread. So the very concept of a dough becoming bread is because of all these gas molecules which are interspersed within a solid medium. A liquid in gas is called as aerosol, and the example of an aerosol is fog or the formation of clouds. A liquid in liquid is called as an emulsion, and milk is an excellent example of an emulsion. A liquid in solid is called as a gel. An example of a gel is jelly and butter. A solid in gas is called as an aerosol, and an example for an aerosol is smoke or dust. A solid in liquid is called as a sol, and a very good example of sols are paints where pigments are mixed in an aqueous or oil medium. A solid in solid is called as a solid sol, and alloys are very good examples of solid sols. So alloys are a mixture of metals. Based on the appearance, colloids can be classified as sols and gels. So if a sol appears fluid in nature, it is called as a sol. If the dispersion medium is water, we call it as a hydrosol or aquasol. And if the dispersion medium is alcohol, we call it as an aquasol, alkosol, or benzosol. However, if the colloid appears as a solid, we call it as a gel. An example of gels are jelly, butter, cheese, and curd. We can classify colloids based on the electric charge. They can be classified into positive and negative colloids. So if the dispersed phase has a positive charge, we call them as positive colloids. For example, ferric hydroxide and aluminum hydroxide, they are examples of positive colloids. And if the dispersed phase has a negative charge, we call them as negative colloids, and examples are silver sol and copper sol. We can also classify colloids based on their affinity towards solvents. So if they are solvent loving in nature, we call them as lyophilic colloids, and if they have a phobia towards solvents, we call them as lyophobic colloids. So this classification is based on their solvent affinity. So you can differentiate lyophilic and lyophobic colloids based on many factors. First, based on the affinity for dispersion medium, colloids which have high affinity, they are called as lyophilic, and colloids which have no affinity or very low affinity are called as lyophobic colloids. And lyophilic colloids, they are easy to prepare just by mixing, shaking, or heating the substance with a dispersion medium. But lyophobic colloids, they require special methods to prepare. And lyophilic colloids, they are highly stable in nature and they do not coagulate easily on adding electrolytes. But lyophobic colloids, they are unstable and they can easily be coagulated by electrolytes. If you look at the reversibility, lyophilic colloids, they are reversible in nature, which means they can go from gel to sol form and from sol to gel form easily. However, lyophobic colloids, they are irreversible in nature. And based on their solvation property, lyophilic colloids are highly solvated, but lyophobic colloids, they are not solvated easily. And lyophilic colloids require a large amount of electrolyte for coagulation, but in the case of lyophobic colloids, a small amount of electrolyte is sufficient. Lyophilic colloids are highly viscous in nature. In fact, the dispersed phase is more viscous than the medium. But lyophobic colloids, the viscosity is the same as that of dispersion medium. So in lyophilic colloids, the surface tension is generally less than that of the medium, but in lyophobic colloids, it is the same as that of medium. Some examples of lyophilic colloids are starch, protein, gelatin, and gum dissolved in water. And that of lyophobic colloids are metals, metal sulfides, and oxides. Let us look at an important property of colloids. So, Colloids show very interesting optical properties. One of them is Tyndall effect. So we would have all seen a picture of this, light passing through a forest, and we can literally see the path of light. So this effect is called as Tyndall effect, and it is exclusively exhibited by colloids. So what is the reason behind it? So if you look at this picture, on the left side you have a solution, and on the right side you have a colloid. And when you pass light through these two solutions, on the left side you do not observe anything much, but on the right side you can literally see the path of light. So this characteristic of being able to see the path of light is because of scattering of light by colloidal particles. So colloidal particles, because the size is intermediate between solution and suspension, they are capable of scattering the light, and that is how we are able to see the path of light. And that is the reason for the phenomenon that we observed in the earlier slide, where when light passes through a forest, we are able to observe the passage of light. So, if you take a colloidal solution in a trough, you pass light through that colloidal solution, and if you try to observe this effect using a microscope, you will be able to easily observe the scattering phenomenon of light. Thank you.